Alright guys, so this is your video for finding real zeros of polynomial functions. So there's a couple different methods that we're going to see. You're going to see most of them in here. There'll be one additional video for using a calculator. So the first thing we need to talk about is this word zero. So there actually are a few words that all mean the same thing, and I'm going to highlight them from this image up here. This image is also uploaded on your Google Classroom. So there's a couple words here that I would like to draw your attention to. So zero, solution, factor, x-intercept. There's one more I'm going to add to this list, and that's also the word root. All of these words mean the same thing. So if you see a question that's asking you for a zero, you know that that's asking you for an x-intercept. Or if they're asking you for a solution, they're asking you for an x-intercept. The reason that I always reference x-intercept is that's the one that we're most familiar with. Most commonly we use x-intercepts, but you know, you're going to see directions with different words. So being aware that all of these words that I've highlighted, in addition to the word root, all mean the same thing. Okay, so let's talk about n. N is your degree. Okay, so n would be the degree of polynomial, and it's always the highest degree. So the reason that this is important is because n tells us two different things. N, if you look at the exact value, that's the number of possible zeros. Okay, so whatever number is your degree, your highest degree, that's how many possible zeros you could have. So if you have something that has a degree of 3, so for an example, if you had f of x equals x cubed, that could potentially have 3 zeros. So this could have 3 zeros. Okay, it could have 3, it could have 2, it could have 1, and it could have none. But at most, that's the maximum number of zeros that it could have is 3, because that's what the degree is. Now, the second thing that n tells us, it also tells us how many turning points we would have. Now, the thing is, it's not just the value of n, it's n minus 1. So n minus 1, that tells us how many turning points. So a turning point is basically where is it switching? Where is it switching from increasing to decreasing? So a turning point, so for instance, if I were to be looking at this function right here, this function has 2 turning points. I have one here and one here, so there's 2 turning points. By knowing that, do you think that you could figure out how many degrees this would have? If we use what we know that the ends are going in opposite directions, so we know odd functions go in opposite directions. If I take 1 away from whatever my degree is, I have 2 turning points. So that means this must have been a cubic function, or to the power of 3, where n is 3. So let's talk about these different methods of finding zeros, okay? We know that n is our degree. We can use that to give us more information or to know when we find enough zeros. But let's talk about how we actually find them. There's a couple different ways. I'm going to show you this first one on the next slide, where you're setting your equation equal to 0 and solve. Generally, this is going to require factoring, all of your factoring methods, and all your different solving methods. Okay, so that's a little bit more algebraic. Then my second method, or your second method, is to just graph. Okay, you could use Desmos, you could use a graphing calculator. You graph and find your x-intercepts. Remember that that word x-intercepts, that's like equivalent to the word zeros. Okay, so finding your x-intercepts on a graph, you can just go with your cursor, go down the curve on Desmos, and that's your x-intercept, that's a 0. The third method, which is what you're going to see in a separate video as well, is using a graphing calculator. You can plug your whole function into a graphing calculator, and using the functionality of your graphing calculator, it can calculate your zeros. So I'm going to show you that in a separate video. So let's do the algebraic, the first method. So we have our function. We have f of x equals negative 2x to the fourth plus 2x squared. They're asking us to determine the maximum number of turning points and also the real zeros. So let's start with the easy. Let's start with the maximum number of turning points. So if we have our n for this problem is 4, that's going to tell us our max number of zeros. If I do n minus 1, which is going to be 4 minus 1, which is 3, that's going to be our max number of turning points. Okay, so that's what we start with. That's going to be all from just the degree. Our degree was 4 to start with. You take away 1, and that's how many turning points you could possibly have. Now we also know that we could possibly have 4 zeros because we're to the power of 4. Let's set our function equal to 0 and then solve and see what we get. So we have negative 2x to the fourth plus 2x squared equals 0. Now this I can definitely tell that I have factors in common. Whenever you have two terms and you see that they have a common factor, factor it out. This is that GCF method. So I see I could take out a 2. I can also take out an x squared. I'm going to take out a negative 2x squared just so that my leading coefficient is a positive. So I have x squared. That's going to be a minus 1 now. Equals 0. When you have two factors being multiplied and they both equal 0, you set them both equal to 0. So you have negative 2x squared to equal 0, and we have x squared minus 1 to equal 0. Solve them separately. So we're going to divide by 2. Oops, that's not 2, that's 0. And then take the square root. So we know the square root of 0 is 0. So that is one of our x-intercepts, or our zeros, or our roots. All of those are meaning the same words. So then we can solve this one. So we're going to add 1, take the square root. Now remember, when you take a square root, you end up with the positive and the negative values. So you actually have 3 zeros. Your function has 3 zeros. You have zeros at the values of negative 1, 0, and 1. So you have zeros at those values, because when we set our whole function equal to 0, factor and solve, those are the values we got. So the big thing to remember, if they're asking for solutions or if they're asking for zeros, remember those are your x-intercepts, and I think that's the easiest way to relate this is to finding your x-intercepts.